So now we're going to talk about a hyperbola. A hyperbola has two symmetric halves, and our standard form of the parabola is going to have two symmetric halves because we know that it is 1 all over x. So this is our parent function for the hyperbola, and this is about generally what they look like. We know based on the video you just watched that we actually have two asymptotes on here. Our first asymptote is where x equals 0, and our second is where y equals 0. So the x-axis and the y-axis are both our asymptotes. So we have our horizontal asymptote, which just happens to be the x-axis. That's when also it is y equals 0. So this is both the y equals 0 line and the x-axis. He's our horizontal asymptote. We have a vertical asymptote where x equals 0, which just also happens to be the y-axis. So we have two. So if you were ever asked, what are your asymptotes? We know that x equals 0 is our asymptote, and so is y equals 0. So we have two asymptotes. And the reason why these are your asymptotes is because if you tried to put x of 0 in here, this would become undefined. Your calculator would say error, and there is no way to make this problem actually equal 0. So this statement right here will never be true. There is no number you can plug into this x value to make this fraction actually equal 0. So that's why the y equals 0 is also a asymptote line, because we're never going to get that answer. Now we need to talk about domain and we need to talk about range. Remember, domain is how far all over on the x's that you go. We go everywhere on the x's because he will always go to the right, and this one will always go to the left. We're always to the left and always to the right. There's one value we never touch. We never touch this x at 0 part. So our domain is all real numbers, but x cannot be 0 because we never actually touch it. So we use every single number except for the 0 line. Can't use it. Range, we go all the way down and we go all the way up because range talks about your y's. So since the range goes all the way down and all the way up, the only number on this that we never touch is when y is 0. So we use every single number except for your y could not have been 0 because we never touch that 0 line right there. No matter how far up we go, we had to skip it. So now we're going to try and graph it. So the parent function f of x is 1 all over x. This is our hyperbola. It's our first one. It's the parent. So we're going to go ahead and use a table because we don't have to do it yet. So we're going to go ahead and plug these values into our calculator to fill in our table. So if you use your calculator to fill in your table, you would have had these values. Yes, your calculator would have errored you at 0, and that's because, remember, that was an asymptote. You can't have x be equal to 0, which is why the domain said x couldn't be 0. He was our asymptote. So I want to graph this over here and see what this is going to look like. First thing that we need to graph is our asymptotes. So here is my x equals 0. Here's my x equals 0 y-axis asymptote. And then here is my y equals 0 x-axis asymptote. And then after that, I'm just going to use the table. So -5, -0.2, -4, and you're just going to fill in and continue with the table. So continue at the table. I would have had my first 5 points, and I didn't do anything in between -0 and 1, but I know that it doesn't cross the asymptote at all, so it continues to go further down. So now I need to do the coordinate point 1, 1, got 2, 1/2, 3, 1/3, and if you keep going down, you'll notice we look like that. We know that he is getting ever so closer to the 0 line, and so he's going to get closer. And this also cannot pass our asymptote, and he's just going to keep going. So we just continue to graph it. So this is our parent function of 1 all over x. So I'm going to write, I have f of x equals 1 over x on that one. And I'm going to write it over here as well so I can keep track of it. Now I'm going to give you a new function. What did we do to this parent function in order to get this new function? I noticed that if I took the original parent, which just happened to be 1 all over x, if I chose to multiply that by 4, I would have ended up getting my new function 4 over x. And let's actually not call him f, let's call him g because he is my new function that I want. If I took the f function and multiplied it by 4, I would end up getting the new function I'm trying to see what it looks like, what graphs. Well, I know from a previous lesson way back in chapters 1 and 2, if I am out here multiplying by 4, it's bigger than 1. So I know that this is end up going to be a vertical stretch. So if this blue line right here is my parent function, and I now want to go in there and I want to graph this, it's going to be vertically stretched from this blue line. So to see what that actually looks like, we're going to do another XY table. Now, I try to make this one a little simpler for us to see. I know that these two sides are symmetrical. So how this one is going to appear is going to be reflected over here, and that's exactly how the new vertical stretch line will be over here. I also know that it got ever so close to 0, so I needed some numbers that were closer to 0, so I saw how it actually worked. So I'm using the numbers 1/4, 1/2, 1, 2, and 3. I'm going to go back to my calculator. I'm going to fill in our table. So when I used my calculator to fill in my table, 1/4 had 16. So my 1/4 is right here, and it's way up past my graph at 16, so I actually can't really even graph it. 1/2 is at 8, so here's my 1/2 at 8. My 1 is at 4. My 2 is at 2. My 3 is at 1 1/3. So I see this blue line was vertically stretched up to here. So we are going to still ever so close, it's going to 0. And this is my G equals 4 over X line. So I see it got vertically stretched. It's going to look about the same over here as well. So since he was 2, 2, he's actually going to be -2, -2. And from here, we're just going to guesstimate and fill in the rest of it. And this red is G of X equals 4 all over X.